Hello, everyone. Today we are going to talk about virtual doctor conversation. Here is Ya Wenzhou and Wenhe Chen. In today's era of information explosion and rapid technological development, AI has penetrated every aspect of our lives, from simple daily tasks to complex decision-making processes, and its application is almost everywhere. Among them, the healthcare sector is undergoing an unprecedented transformation thanks to advances in AI technology, especially in the provision of virtual medical consultation services. We are committed to making our remote robot doctor achieve the following goals. First, immediate health consultation and support. Provide users with 24-hour, 7 days health consultation services, allowing access to medical advice and information anytime, anywhere. Second, disease prevention and health management. Help users prevent disease and improve lifestyles through health education and self-management advice. Third, primary screening and guidance, capable of conducting preliminary symptoms analysis and providing advice on seeking medical attention or guidelines for emergencies. Fourth, mental health support, offer mental health consultation and stress management advice, helping users deal with emotional and psychological issues. By achieving these goals, we aim to improve access to healthcare in remote or resource-limited areas. In addition, reducing pressure on the healthcare system is another benefit, such as self-service, reducing unnecessary hospital visits, and enabling doctors to focus on more urgent and complex cases. Finally, personalized health management through virtual doctors can also promote health awareness and education. The intersection of AI and healthcare has led to the development of numerous platforms aimed at improving patient outcomes through advanced computational techniques. Significant among this is the Ada Health app, which leverages complex algorithms and extensive data analytics to deliver personalized health assessments. This platform use of big data to tailor medical advice reflects a broad trend towards customization in patient care, a concept we have furthered through sophisticated modeling techniques. Babylon Health exemplifies the integration of AI chatbots with telemedicine, combining natural language interfaces with video consultations to enhance patient engagement and healthcare accessibility. Our approach differs in its underlying technology stack and focuses more on deep data analysis rather than real-time interaction. Bowie Health utilizes machine learning to analyze self-reported symptoms for initial medical advice, particularly leveraging NLP to interpret user inputs. While Bowie Health emphasizes initial symptoms assessment, our virtual doctor symptom expands on this by employing a robust set of AI methodologies to provide a more detailed diagnostic insights. By analyzing these pioneer technologies, our project not only identifies the strengths and limitations of current solution, but also carves a niche for enhanced autonomy and learning capability in virtual healthcare consultation. This distinction highlights the future direction of our research and the potential for significant contribution to the field of AI in healthcare. In the development of collecting datasets, we undertook an extensive data collection effort from the NHS website and Illinois Department of Public Health website, which are reputable sources of medical information. Our result was collecting a comprehensive dataset comprising 359 distinct diseases, along with their corresponding symptoms and treatments. Given the structured nature of the NHS Inform site, which alphabetically lists disease from A to Z, we mainly employed a systematic web scraping approach and manually fulfill the missing values and do some correction.
So here is our implementation method. We are currently facing three challenges. The first one is the lack of large label datasets. So we Googled online, many datasets have only a few diseases. And the second one is advanced technology is not public. For example, ADA Health app. We already know that this app is using the NLP techniques, but we don't know what the exact algorithm it is and which one did they use for the implementation. And the third one is computers don't have enough computing power and don't have a lot of memory. So in our local computers, we can only handle a few small data sets. And based on those challenges, we have our method to solve it. The first one is matching the symptom description entered by the user with the symptoms of all disease recorded in our database. And then based on the matched disease symptoms and output the name of the disease and the corresponding treatment. So here's our potential approaches. The first one is using DF, IDF plus cosine similarity. It is really useful and because it is simple and easy to implement, suitable for the text similarity comparison. And the second one is the BERT and is the variance. For example, BioBERT, it is the ability to understand complex relationships and the context. And actually, we did try the BioBERT and the normal BERT. And the third one is GPT. It is efficiently generate large chunks of coherent text. And the fourth one is the Word2Vec. It's generating. It's really similar to the BERT, and they can all capture the relationship between words. And the fifth one is the LSTM or the GRU network. It is really good because it is the ability to handle variable length tests suitable for the time series or series data. And the sixth one is the CNN. It is very efficient in extracting local features. And then the seventh one is machine learning. We can use the SVM, random forest, or the logistic regression. So the label data is set to trained and the patient input is classified. And the last one is we can use rule-based systems. So the main idea of this is the set of if-then logic. For example, if A and B then C. There's an example. For example, if there's a fever and there's a cold, then something else, then what disease it is. So based on those potential approaches, we develop our own approaches. We found that GPT is only generated large chunks of current tests. We don't think it is suitable for our goals. And the same as the Word2Vec. For the fifth LSTM, since it is only suitable for the time series data, we don't have it. So we don't think it is work for our approaches. And the sixth one is CNN. It is very efficient, but it's only on extracting the local features. For the seven, since we don't have a lot of labeled data sets, so we cannot use this one. And the rule-based system, it is useful, but it is simple. So it is hard to solve the complex data. So based on this thing, we develop our own approaches. We use the TF-IDF and the BERT. So we have 6 steps. The first step is we use a TF-IDF to do the feature extraction. So feature extraction of a symptom text data using this one. And the second one, we can use a BERT embedding. We use a BERT for the especially the system transformer model for deep learning. BERT-based system embedding. This embeddings capture the deep cinematic information of the system test and then we do the feature combination. So the TF-IDF feature matrix and the BERT embedded result are stacked. So it's from a comprehensive feature matrix, which can utilize both traditional TI-IDF features and the symptom features provided by deep learning. And the next step, we can do the clustering. Symptoms are grouped using the k-means clustering algorithm. And the phase one is the anomaly detection. We use the anomaly detection, use the isolation forest algorithm to detect unusual or rare symptoms. Then doctor will know that whether this disease is anomaly or normal. And then in the last step, we use the BART model generates the summaries. So in this step, the patient will easily to read the treatment recommendation. So here is our result. When the user input, I don't feel well and can't go to work to do the normal activities and so on in details, our chatbot will opt three main things. The first one is 5 diseases with symptoms similar to those the user described and how similar they are. As the user input, I don't feel well and go to the work or do the normal activities. So there's five diseases really similar to the symptoms the user described, which are those 5. And the second part, our chatbot will output the disease with the most similarity to the user described and its probability. For example, coronavirus, and the probability is almost 50%. I would like to emphasize this 50% is not the probability of this patient have this disease, it's the similarity of the symptoms. If they only have a 50% similarity of the symptom, which means that there is maybe like 80% or 90% probability the patient have this disease. Because the similarity of two symptoms are not always the same, but they are similar. Yeah. So the third one is the summary of treatment recommendations. For example, and the user inputs I don't feel well, and it will generate the treatment recommendations for example, drink fluid like water to keep yourself hydrated and get plenty of rest. Wear loose, comfortable clothing, such as like that. And also we did the data visualization of the output. For example, we can see from here. So we can see that the coronavirus have the higher similarities than other 4, which means that this person maybe have a coronavirus. And this is the word clock for the treatment recommendation. We can obviously say that we need to drink more water. So the patient look these pictures, they know what should they do. And here's our system overview. For the back end, we have 4 main things. The first one is Flask. We use the Flask framework as a backend core to handle HTTP request and response. And the second one, we use machine learning integration. So we integrate multiple machine learning models to process system data, including test vectorization, clustering, test summary generation. And we also did data processing. We use Panda and NumPy for data loading and pre-processing, including reading Excel file and processing symptom descriptive data. And for the model application, we use the TF-IDF and the systems transformers are used for test feature extraction, k-means clustering, and isolation forest anomaly detection for data analysis. And in the end, the BART model is used to generate a summary of treatment recommendations for symptoms. For the front end, we use the HTML5, CSS3, JavaScript to build a user interface that allows user to enter symptom descriptions and display response from the back end. We also use the AJAX communications. We use this Fetch API in JavaScript to communicate with the Flux backend to submit symptom data and receive analysis result. So here is our here's our overview of our website. We can tap the symptom right here and click the same button. For example, when the user tap the symptom for I don't feel well and can't go to work or do the normal activities, and click the same button, and the chatbot will reply it for 5 diseases with symptoms similar to those you described, as I said before. So for our symptoms, there are 3 improvements. For the first one is we need to reach front-end functions. For right now, we don't have visualization on our website, but in the future we maybe will. And we can also implement the user account. Maybe the user can log in their account, and we can record the conversations, and we can do a personalized data like recommendation for the next time. And the second one is expanding the data set to extend disease data and resolutions. As I said, we don't have lots of data sets, so the accuracy is maybe that not high. So we can expand the data set, and we can collect the labeled data set to training our model. And the third one is adjust the model parameters to increase its accuracy. Yeah, like our accuracy, we are in a beginning of the model, so we will like increase our accuracy in the future. So here is our conclusion part. All in all, we implement a remote chat doctor for medical data analysis and symptom diagnosis. The remote doctor can describe the symptoms entered by the user and determine the user's underlying disease. And according to the user's underlying disease, and recommend the corresponding treatment plan. I know our accuracy is not that high, but we test it manually. We found that we manually tapped 5 diseases, and it's really similar to the one we chose. And we found out the chatbot actually did find that disease, which means we can accept this result. But we maybe need to do a further analysis in the future. Yeah, like. So we, in our chatbot, we solve the problem of long waiting time for doctor appointments, which means that the patient don't need to move for the doctor appointments. They can directly ask our virtual doctor. And we solve the problem of cost of medical consultation for patients. So for this one, like the people need to pay for the medical consultations. But for here, we maybe have a really cheap price, which means reduce the cost of medical. And here are 5 more benefits we got. So we can take the pressure of the traditional healthcare system, which means that the people in the hospital will like accept lots of patients. And we take the pressure of the traditional healthcare system. And the third one is 24-hour and 7 days ability, which means that they can directly ask our virtual doctor. And then the next one is increase access to healthcare. And the last one is formally develop software and extend the functionalities. And here's our reference page. And thank you for watching. Hi everyone, my name is Wenhe Chen. Today, let me introduce how are we going to use our app. So this is our GitHub website. You can read the description of our project through here. And this is the example for how are we going to use the website. For example, we can tag the symptoms of some disease or you're feeling here. And this is the important thing we are going to do is how I'm going to introduce how to use this thing. So for the first step, we need to download the static file and the app.py. So for those two files, we can find those two files from the library. So those we can download this the static file and the app.py through the library section. After we download these two files, we can run the Python app.py on the terminal, which is our terminal. And we can open the terminal right now. Let's see, we type the Python app.py. And we can see that it tell us the current directory and what files are included in these files. And probably we need to wait for 30 seconds. And since it shows that it's running on the HTTP dot this link, which means that we can go ahead and open this link to use our web. For example, so we already run the Python app.py on the terminal. Then we open this link. We can directly click on this link. In the local browser, we can open it in Chrome or Microsoft Edge, something like that. Okay, so this is our website looks like. And through here, we can, this is like a simple website. We can tap our symptoms right here, and we can click on the send button. For example, we can tap hi first. Since here are some ways you can start with, we can tap hi or hello. Let's say hello. So after we tap hello here, and the chatbot will reply it automatically. It said, hi, please enter your symptoms in details. I will provide a comprehensive analysis based on the symptoms you describe and identify potential disease and risk. In case of emergency, please dial 911 directly for help. So, okay, if we are feeling not well, we can type our symptoms, for example. So for me, I type in I'm not feeling well and cannot go to work or do normal activities. I have a slight fever. I have been coughing with a sore throat and a runny nose. I'm hungry and I can't eat any food. I seem to have lost my sense of taste and eat without taste. So after I type these common words to describe our symptoms, we can click on the send button. So it's running on the terminal. So maybe after 20 seconds or 30 seconds, we will get the result from the robot. So the robot said the first thing the robot reply is the 5 diseases with symptoms similar to my description and how similar they are. So here's the five diseases we can throw here, and there will be similarity behind the disease. We can see that the disease most similar to the one I described, and its probability is the coronavirus, and the similarity is almost 50%. And based on that, the chatbot, the robot will also give us the treatment recommendations. So it said drink fluids like water to keep yourself hydrated and get plenty of rest. Wear loose, comfortable clothing. Do not try to make yourself too cold. Take over-the-counter medications like paracetamol. Always follow the manufacturer's instructions. So those are the recommendations. And if we finish for our website, we can click on the fresh button and the history will disappear and start we can start another like description. We can have a new symptoms. So mainly like we implement a virtual doctor conversations. We can talk to the virtual doctor. We can type our symptoms. We can describe our symptom and type it in and send it to the virtual doctor, and it will reply it automatically.